Bright Tuty. Every student matters.
Hello students, my name is Sanjay Jain. Let's do this exercise on triangles on the same base and between the same parallels. So let us start with question number 1 here. In this figure, E is any point on median AD. So AD is the median, that means this segment BD is equal to segment DC, number 1. Now E is any point on it. Now we need to show that area of triangle ABE is equal to area of triangle ACE, right. So let us start with this concept, that let us say if I have got this triangle, right, and I draw a median from this point. Now areas of these two triangles will be equal. We have studied about it because their bases are equal and their height will be same. If I drop a perpendicular, now this height, if I name it by h, this will be height for both the triangles, this one, and base is equal in length. So the areas will be equal, right. Similarly, in this particular figure, AD is the median, so we will write AD is the median, hence area of triangle ABD is equal to area of triangle ACD, right. And now once you say this, what you can do is you can look at this segment ED. ED is acting as median, ED is the median in triangle BEC, right. So can I say that the area of this triangle, area of triangle BED is equal to area of triangle ECD? Yes, because of the same concept here. Whenever you see a median like this in a triangle, right, let us say this is the median. Now these two triangles will have equal areas, and concept is pretty simple because their bases, their respective bases are equal in length, because this line is a median, so it will bisect this line on which it is falling, right. So their bases are equal in length and their height is common, right. They have same vertex, so their height is same. Okay, so now we have seen that area of triangle ABD is equal to area of triangle ACD, and area of triangle BED is equal to area of triangle ECD. If I subtract equation 2 from equation 1, or let me tell you in simple terms, if I subtract area of this triangle from this bigger one, what I'll get is I'll get area of this triangle. Can you subtract areas like that? Yes, you can. You can add areas, you can subtract areas, right. Area cannot be negative, of course, but area is a region, right. Area is a region which you can measure, so you can add or subtract areas, and we have discussed this in our introduction part also. So now I can say area of triangle ABD minus area of triangle BED is equal to area of triangle ACD minus area of triangle ECD. Hence I can say area of this triangle, that is triangle ABE, is equal to area of this triangle, that is triangle AEC, right. And this is what we had to prove, alright. So this was a simple concept, that these two areas were equal, this area and this area, these areas were equal, and these two areas were also equal, this smaller one and this smaller one. So we subtracted equals from equals, hence the results were also equal. And what were the result? Area of this triangle and area of this triangle. So these were equal, alright. Now in a triangle ABC, E is the midpoint of median AD. Show that. Let us first of all draw this figure. This is triangle ABC and this is median AD, and whenever you draw a median you mark this segment like this, so that you know or you can easily visualize that these two segments are equal in length, right, because AD is the median. Now area of triangle BED, E is midpoint of median AD. So let us say this is point E and this is E is the midpoint, so this segment AE is equal to segment ED. Okay. Now area of triangle BED, for that let me join B with E. So we are looking for area of this triangle and we will compare it with the area of triangle ABC. Now we know property of medians, AD is the median, hence I can say area of triangle ABD is equal to area of triangle ACD, right, and both of these are equal to half of area of triangle ABC, right, because if I add these two areas I will get area of triangle ABC, and these two are equal, hence they are equal to half of area of triangle ABC. Now this much is clear. All right, now the next step, in this triangle ABD, BE is the median, BE is the median. So can I say area of triangle BED is equal to area of triangle BEA? Yes, because BE is median, so area of this triangle and this triangle will be equal. Okay, and if these are equal, these will also be equal to half of area of triangle ABD, this one, this bigger one, ABD. Right. What I mean is, let us say I have got this triangle. If I divide this triangle into two parts and I say that this area and this area, these are same, okay, what will be the area of bigger triangle? The area of bigger triangle will be 2A, which is double of this triangle and area of this triangle also. So when I say that this area is equal to this area and is equal to half of area of this bigger triangle, this is what I mean. Okay. So here I can say it is equal to half of area of triangle ABD. Now I just need area of triangle BED, which is this one, right? Area of triangle BED I need on left hand side. On right hand side, let me see this one. This is area, half of area of triangle ABD. So let us write it here, half of area of triangle ABD. Now can I write area of triangle ABD in terms of area of triangle ABC? Yes, area of triangle ABD is half of area of triangle ABC. So let me write it here, half of area of triangle ABC. Okay, this is what I have written here. So 1/4 of area of triangle ABC is equal to area of triangle BED. Okay, this is how you will prove this result. And when you look at it without writing these all, if you simply look at this figure, now can I say, let me change the color. Just by looking at this figure, I will know that area of this portion is equal to area of this portion. Let us say area of this portion is A or A1. Okay. So what will be area of this entire portion? It will also be A1, right? Now this is the median. So I'll know this area will be A1 by 2 and this area will also be A1 by 2. Now I know the complete triangle will have area twice of A1, and this triangle, this little triangle BED has got area A1 by 2, which is 1/4 of this, right? So you could have simply seen this without writing all these steps if this question came in a competitive examination. Okay, so you don't have to write all these steps, you just have to understand that if I draw a median, it will divide the triangle into two equal areas. Okay. Show that the diagonals of parallelogram divide it into 4 triangles of equal areas. Now, this question is also pretty simple if you understand the concept of median, that medians will divide a triangle into 2 triangles of equal areas. Let us say this is the parallelogram ABCD. Now, I will change the color. Okay. Show the diagonals divide it into 4 triangles of equal areas. So, this triangle, this triangle, this triangle and this triangle. These triangles will have equal areas. This is what we need to show. First thing that you should know is that diagonals of a parallelogram bisect each other. Right? Hence, I can say segment AO is equal to OC and segment OD is equal to OB. Once you know this, now the concept is pretty simple. See, AO is median for triangle ADB. For triangle ADB, AO is the median, right, because it bisects this side DB. So, it is obviously median. Hence, I can say area of triangle AOD is equal to area of triangle AOB, right. So, if this area is, let us say, x, this will also be x. Okay. I am not saying that you take this x as this area. These terms I use just for you to visualize the problem clearly. So, if this area is x, this area is also x. Now, this we understand due to this median AO, alright. Okay. Now, for triangle ADC, this triangle ADC, DO is the median because DO divides side AC into 2 equal parts. So, DO is median. Hence, I will say area of triangle AOD is equal to area of triangle DOC. Hence, can I say this area is also x, because these 2 areas I have proved equal because of this median here. Similarly, this is median for triangle ABC, hence this area and this area will be equal, or you can consider this as median, then this area and this area will be equal. So, let me consider this as my median of triangle DCB. In triangle DCB, CO is the median. Hence, area of triangle DOC is equal to area of triangle BOC. Area of triangle DOC is equal to area of triangle BOC, which area of triangle DOC I have taken as x. So, this will also be x. Now, you can see all these areas are equal, right. Hence, I can say area of triangle AOD is equal to area of triangle AOB is equal to area of triangle DOC and is equal to area of triangle BOC. So, the diagonals divide a parallelogram into 4 triangles having equal areas, right. This was the purpose of this question. Now, this is basic understanding, right, that should carry forward with you without this question also, right. This is not a question, this is a concept that you should understand always, that whenever you see a parallelogram, you should keep in your mind that its diagonals will divide into 4 triangles, and these triangles, let us say one of these triangles have area A. So, this area will also be A, this area will also be A, this area will also be A. This is what you need to understand. Because of this, you will also understand that this area is A, this area is A. So, if I combine these, let us say this triangle, now how much area this triangle has? This has got 2A area, A plus A, 2A, and the triangle below it, that is this triangle, it has got area 2A. So, this diagonal, this diagonal divides the parallelogram into 2 equal areas. Similarly, this diagonal here, this also divides the parallelogram into 2 equal areas, A plus A, A plus A. Okay, and you can draw some more conclusions also, that area of this triangle here, area of this triangle is 2A and area of this triangle is 2A. So this strengthens our concept that the areas of triangles between the same parallel lines and having the same base are equal. Okay, so these are the concepts that you can learn from this question. Now ABC and ABD are two triangles on the same base AB. Okay, if line segment CD is bisected by AB at O, so this segment OC is equal to OD. This is given in the question, and we need to show that area of triangle ABC is equal to area of triangle ABD. Now using the concept of median, if you just want to visualize this, how I am going to proceed in this question is, this goes like this. This AO is median for triangle ADC. So I can say that area of this triangle and area of this triangle is equal. Okay. Similarly, BO is the median for triangle BCD. So area of this triangle here is equal to area of this triangle. Okay. Now let us say this was A, so this was also A. If this is B, this will also be B in terms of area. Now if I add A and B, area of this triangle ABC is A plus B. Similarly, area of triangle ABD is also A plus B, hence these are equal. Okay. So we will use the simple concept of that the median divides a triangle into two equal areas to prove this question. Now OC is equal to OD, hence AO is the median in triangle ACD, hence area of triangle AOC is equal to area of triangle AOD, okay, which I have assumed as small a here. Similarly, BO is the median, hence I can say area of triangle BOC is equal to area of triangle BOD, which I have taken as small b. Now if I add these, area of AOC and BOC, so area of AOC plus area of BOC will be equal to area of AOD plus area of BOD. And what is this area? Area of AOC plus BOC, this is this complete area, this complete area. Right. So it is area of triangle ABC. Similarly, you can see that these areas combined will give you area of triangle ABD. This is what we had to prove here. Okay. Now DEF are respectively the midpoints of sides BC, CA and AB of a triangle ABC. So let us first of all draw this triangle and visualize the problem. Then we will write the solution. You can write the solution yourself if you once you understand the problem, right? So let us say this is triangle ABC. D is the midpoint of side BC. So D is the midpoint, so I'll denote it by marking these segments equal. Okay, CA has got midpoint as E, so this is E here. Let me mark it by 3 lines here. Okay, and F is the midpoint of AB, so let us say this is F, right? Now show that BDEF is a parallelogram. BDEF, let me join these. Okay, now I will also join F and D. So the first question is, show that BDEF is a parallelogram. For this, you should be clear about midpoint theorem. If I join midpoints of two sides of a triangle, then the line joining these midpoints will be parallel to the third line, and it will also be half of the third line. So if I say F is midpoint of AB, E is the midpoint of AC, hence FE is parallel to BC. Why? Because of midpoint theorem. Okay, FE is parallel to BC and FE is half of BC, right? There is another segment which is half of BC, which is BD. Hence, it is also equal to BD, because BD is also half of BC. FE I have proved to be half of BC. Now, you see, FE will also be parallel to BD, because BD is just a segment of BC, right? So FE is parallel to BD, hence FE is parallel to BD and FE is equal to BD, and this much information is enough to prove that quadrilateral BDEF is a parallelogram, right? If a pair of sides of a quadrilateral is equal and parallel, then it will definitely be a parallelogram. So quadrilateral BDEF is a parallelogram. So first part of this question is done. Second, area of DEF is 1/4 of area of ABC. So we are talking about this area here. Now, since I have proved BDEF to be a parallelogram, CD is also equal to FE and CD is also parallel to FE. So for second part, CD is equal to FE and CD is parallel to FE. If you are wondering how is it true, because CD is segment of BC which FE is parallel to, right? So CD is also parallel to FE and CD is half of BC. Similarly, FE we have proved half of BC. So CD is equal to FE and CD is parallel to FE. Hence I can say FECD is a parallelogram. FECD is a parallelogram, right? So this is another parallelogram here. Similarly, can you prove that AEDF is a parallelogram? Yes, I can prove. AEDF is also a parallelogram because of the same reasons. Why? Because you can say E is the midpoint of AC and D is the midpoint of BC. Hence, DE will be parallel to AB and will be half of AB. So AF is already half of AB, hence using this similar line of logic you can say AEDF is also a parallelogram. Now see, all of these three are parallelograms. Which three? This one is a parallelogram, right? So diagonal of a parallelogram divides it into two equal areas. So if I say area of this triangle is A, what will be area of this triangle? This will also be A. Now let me show you another parallelogram. This here is another parallelogram that we have proved, FECD, and DE is its diagonal. So it will also divide it into two equal areas. So if this is A, this will also be A. Similarly, let me take some other color. This is another parallelogram, right, which we have proved here that BDEF is a parallelogram, first part. So if this is A, this part will also be A, right? This area will also be A. Now you can see these four areas are equal, right? And area of DEF is small a. So can I say area of triangle DEF is small a and area of triangle ABC is equal to A plus A plus A plus A, that is 4A. Hence area of DEF is 1/4 of area of triangle ABC. If you don't want to use these symbols for area, you can simply write these name of these triangles, that area of triangle FBD plus area of triangle FED and so on. Okay, let us look at this one. Area of BDEF, which is this parallelogram here, is half of triangle ABC. This I leave to you. Why? Because I have already shown you that this triangle has got area small a, this triangle has got area small a. So combined this is 2 into 8, that is 2A, and area of the bigger triangle ABC is 4A. So area of parallelogram BDEF is half of area of triangle ABC. Okay, you can write it in words like this, that we have already shown area of BFD, let me write it here, area of BDF is equal to area of DEF is equal to area of DEC, area of AFE, okay, which is equal to 1/4 of area of triangle ABC. So if I add any of these two, let me add FED and FBD, that will give me half of area of triangle ABC. I hope you understand this and you can do it yourself. I have given you enough explanation for this. Okay. Now in figure, diagonals AC and BD of quadrilateral ABCD intersect at O such that OB is equal to OD. Okay, these are equal. If AB is equal to CD, so AB is equal to CD, then show that area of triangle DOC, that is this triangle here, is equal to area of triangle AOB. Right. So we have to show these areas to be equal. First of all, let us draw a perpendicular here in triangle DOC, and let me draw a perpendicular in triangle AOB. Okay. So now see, if we consider we have already proved in a previous question that AO is acting as median in triangle ABD. Let me show you. Let me first explain it to you. See, AO is median for triangle ABD. So this area and this area is equal, right? Similarly, CO is median for the triangle CBD. So this area and this area is equal. So can I say that area of this complete triangle ACD is equal to area of triangle ABC? Yes. Okay. So I am going to proceed like this. Now these areas are equal. So if I draw perpendiculars, let me drop a perpendicular from D to side OC and from B to side OA, right? See, AO is the median, hence area of triangle AOD is equal to area of triangle AOB. Okay, CO is the median, hence area of triangle COD is equal to area of triangle COB. Now if I add AOD and COD, that is this side, it will be equal to sum of areas of AOB and COB. So which will finally give me that area of triangle ACD is equal to area of triangle ACB. Okay. If their areas are equal, can I say these perpendiculars DM and BN will also be equal? Yes, because they have got same base AC. What I mean to say is, area of triangle ACD is what? Half into AC into DM, and area of triangle ACB is equal to half into AC into BN. So DM and BN will be equal because I can cancel these, right? So DM is equal to BN. Now see, AB is already given as equal to CD, DM I have proved equal to BN, and these angles are 90 degrees each. Can I say by RHS congruency rule, this triangle and this triangle, these triangles are congruent? Yes. So I will make this statement here, that in triangle DCM and triangle BAN, DC is equal to BA, DM is equal to BN, and angle DMC is equal to angle BNA. So by RHS congruency rule, triangle DCM is congruent to triangle BAN. Once you have proved these to be congruent, you can say by CPCT this angle is equal to this angle, right? Also, let us say this angle is alpha, so this angle will also be alpha. Now, what are these angles? These angles are alternate interior angles, right? So line CD will be parallel to AB. So from here I can say angle DCO is equal to angle BAO. Angle DCM is equal to angle BAN, and I have considered them to be alpha, which are alternate interior angles. Hence I can say line DC is parallel to AB. Now you tell me, DC is parallel to AB, DC is given equal to AB, and DC is equal to AB because this is given. What does these two statements combined mean? That DCBA is a parallelogram. Why? Because DC and AB are opposite sides of a parallelogram. These are equal and parallel. DC and AB are opposite sides of a quadrilateral, and these are equal in length, and also we have proved that these are parallel. So once you can prove that a pair of opposite sides of a quadrilateral is equal and parallel, you can definitely say that this is a parallelogram. So DCBA is a parallelogram. Once you have reached to this conclusion, now these questions are 5 seconds questions. See, area of DOC is equal to area of AOB. Yes, we know that it is a parallelogram, okay. DCBA is a parallelogram, and in a parallelogram the diagonals divide the parallelogram into 4 equal areas. So we can say this area is equal to this area. We can also say that this is equal to this and this also. We have just proved it above. How will you prove the second part? DCB and ACB. See, DCB and ACB are two triangles on the same base BC and between parallel lines AD and BC. Hence their areas will be equal. So these are also very simple to prove. There is another way to prove it. You know this area and this area is equal. So let us consider these to be A units. So this will also be A units, this will also be A units, because of the property that diagonals of a parallelogram divided into equal areas of 4 triangles of equal areas. So these are A each. Now see DCB. DCB has got area 2 of small a or 2a. ACB has also got 2a. So these are equal. Now this you can prove, this you can prove easily. Look at this. ABCD is a parallelogram. DCBA and ABCD are one and the same thing. So this we have proved already. This is about this question. Okay. So what I have done in this question is I have proved this third part, that ABCD is a parallelogram, right? This I have proved. Now in a parallelogram we know that diagonals divide the parallelogram into 4 equal areas. So this area, this area, this area and this area are equal. Out of these we had to prove that this area is equal to this area, which is a natural consequence of this being a parallelogram. Secondly, we had to prove that this area is equal to this area, right, which is another consequence. Alright, I hope you understand this. This is a little unconventional approach, but I have told you so that you can understand this question. You should not cram this. You have understood this, you can write these yourself. D and E are points on side AB and AC respectively of triangle ABC. Let us say this is triangle ABC. D and E are points on AB and AC, such that area of triangle DBC, let me join D and C, is equal to area of EBC. So this is equal to this area. Now we need to prove DE is parallel to BC. This question is 5 seconds question, as you know area of DBC is equal to area of EBC. Now DBC, triangle DBC and triangle EBC lie on same base BC and their areas are equal. Their areas are given equal. Hence I can say their heights, or you can say altitudes, are also equal, right? If these areas are given equal, they lie on same base BC, so their altitudes will also be equal. This will also be equal to this one. Okay, so if their altitudes are equal, then this point D and point E are at the same distance from BC. Hence, if I join DE, it will be parallel to BC. Okay, hence DE is parallel to BC, which is what we had to prove. Okay, because these are equal. Okay, so you can imagine also in other ways, if you have not understood this from the distance perspective, you can see now. If you look at this quadrilateral DEMN, in this quadrilateral DM is equal to EN, because their areas are equal, these two triangles, and their base are equal, so their heights will naturally be equal. Now DM is equal to EN, hence, and DM and EN are parallel also. DM is parallel to EN. Why? Because these are perpendiculars on the same line BC. So can I say DMNE is a parallelogram? Yes, hence DE is parallel to MN, and which is part of BC, so DE is parallel to BC. So this is very easy to understand. And if you don't understand why their heights will be equal, I have explained it enough. Otherwise, what you can say is half of BC into DM is equal to half of BC into EN. This is the statement you can make based on the fact that their areas are equal, right? Then you can cancel these and show that these are equal, right? Now XY is a line parallel to side BC of a triangle ABC. Let us say this is triangle ABC, and XY is a line parallel to BC. Okay, if BE is parallel to AC, and CF is parallel to AB, meet XY at E and F. So let me extend this line, then it will make sense. I have got a line passing through B which is parallel to AC, right, and this is BE. Similarly, I have got a line parallel to AB, CF, and this was XY. Now what I need to prove is area of triangle ABE, area of triangle ABE, that is this triangle. Let me complete it. Will be equal to area of triangle ACF. This is what I have to prove. Now see, and let me denote that this line is parallel to this line. Okay, once this much is clear, now you can see line BE is parallel to CY, BC is parallel to EY. XY is a line parallel to BC, so can I say BC is parallel to this line EY also? Yes. If these are parallel, BCYE is a parallelogram because pair of opposite sides are parallel to each other. So it is a parallelogram. Similarly, I can also see that BX is parallel to CF and XF is parallel to BC. Hence, BCFX is a parallelogram. Now, what about these two parallelograms? What is special about these is that they lie on the same line BC, or they lie on the same base BC. These two parallelograms BCYE and parallelogram BCFX have got same base BC and lie between same parallel lines, Which are those parallel lines? BC and XY, or you can say EF. Hence, these parallelograms have equal areas. So, area of parallelogram BCFX is equal to area of parallelogram BCYE. Now, let me show you the diagram first. Let me use another color. If this area of parallelogram BCYE is equal to area of BCFX, right? These areas are equal, and this area is common to both these parallelograms, right? So, if I subtract it from both the parallelograms, I will get this area equal to this area. What I mean is, if I subtract area BCFX, if I subtract area BCYX from it, and on the right hand side also, what will I get? I will get this triangle and this triangle. So, area of triangle BEX, let me see, BCFX minus this area will give me area of this triangle CFY, and here I will get area of this triangle BXE, right. So, these areas are equal. This is what we know now. And another thing, now I need to look at these two triangles, this triangle and this triangle. Okay. See, these two triangles have got equal areas. This triangle and this triangle have got equal areas, and they have got same heights because these lie between same parallel lines. So these heights are also same. So these two triangles have got equal areas. They have got same heights. What about their bases? Their bases will also be equal, right? So I can say XE will be equal to YF. Why? I will tell you. I know half into EX into, let me denote it by BM and this by CN. Half into EX into BM is equal to half into YF into CN. Now BM and CN are equal because these are distances between same parallel lines. So I can cancel these. 1 by 2 can also be cancelled. EX will be equal to YF. This is what you need to write. Once you say that EX is equal to YF and these two triangles, this triangle and this triangle, have got same vertex. So their heights are also same. If I drop a perpendicular and extend this line till here, this will act as height for this triangle and this triangle also. So their bases are equal in length, their height is same. So these two triangles will also have equal areas. So area of triangle AEX, is equal to area of triangle AFY. Now see, if I add AEX and BXE, so this plus this will definitely be equal to this plus this, because equals are added to equals and the results will also be equal. I hope you have understood this concept. This, for these two triangles, I just subtracted this common area from the equal parallelograms, and for these two areas I proved that their bases are equal and their heights are equal, right? So their areas will also be equal, and then I added these areas. Okay. Side AB of a parallelogram ABCD. So ABCD is a parallelogram first of all. Okay. And a line through A and parallel to CP meets CB produced at Q. So this is a line AQ parallel to CP. So these two lines are parallel. So let me denote it by these symbols. These two lines are parallel, and then parallelogram PBQR is completed. This is a parallelogram PBQR, that means QR is parallel to PB and PR is parallel to PQ. Show that area of ABCD is equal to area of PBQR. Area of ABCD is equal to area of PBQR. Alright, now see, if I complete this triangle ACQ, this triangle, right, and this triangle APQ, triangle ACQ and triangle APQ will have same area. Why? Because these lie on same base AQ and between same parallel lines AQ and CP. So can I say area of ACQ is equal to area of APQ? Why? Because these lie on same base AQ and between same parallel lines AQ and CP, right? So these two areas are equal. Now what about this area? If area of AQC is equal to area of APQ, can I subtract from both sides this area ABQ. If I do that, let me first do that. If I subtract area of ABQ from both sides, what will it give me? It will give me this triangle. So area of triangle ABC is equal to, and this difference will give me area of this triangle, area of BPQ. Okay. So these two areas are equal. This is what I proved. Now you see, this is a parallelogram. Let me denote it by A. This area is A, this area is also A. This is a parallelogram ABCD. So diagonal AC divides it into two equal areas. So this is also A. Similarly, this is a diagonal for parallelogram PRQB. So this is A, this will also be A. Hence, areas of these two parallelograms ABCD and BPRQ are also equal and equal to 2 of small a. So this is nothing but half of area of parallelogram ABCD, and this is nothing but half of area of parallelogram PRQB. Why? Because diagonal AC divides parallelogram ABCD in two equal areas, and diagonal PQ divides parallelogram PRQB in two equal areas. Once we understand this, we can cancel half on both sides. So area of parallelogram ABCD will be equal to area of parallelogram PBQR. Okay, this is how simple it is. Diagonal AC and BD of a trapezium ABCD. Let me draw this trapezium first with AB parallel to DC. So ABCD, this line is parallel to this line, and their diagonals AC and BD intersect at O. Okay, I need to prove area of AOD, that is this area, is equal to area of BOC, this area. Okay, so now imagine in your mind base CD and triangle ADC. Okay, and with the same base CD another triangle CDB. These two triangles will have equal areas because they lie on same base CD and between same parallel lines AB and CD. Okay, so these have equal areas. If I subtract this common area from both sides, I will get this triangle, area of this triangle equal to area of this triangle. So what I mean is area of triangle ACD is equal to area of triangle BDC, because these triangles lie on same base DC and between same parallel lines AB and DC. Hence their areas are equal. So subtracting area of triangle DOC on both sides, so I can say area of ACD minus area of triangle DOC will be equal to area of triangle BDC minus area of triangle DOC. I can subtract common regions from both sides. Now this gives me area of triangle AOD. It is equal to area of triangle BOC. This is what I had to prove. So it is proved. Okay. These questions depend on your visualization. If you can visualize the problem, these are 5-10 seconds problems. Okay, you can directly write the answer just by looking at the question. Now ABCD is a pentagon. Okay, ABCDE is a pentagon. A line through B parallel to AC meets DC produced at F. That means this line is parallel to this line BF. Okay, show that area of ACB is equal to area of ACF. This is a pretty simple question. These areas are equal. Let me give you the reason directly. Because these triangles lie on same base AC and between same parallel lines AC and BF. Hence their areas are equal. Now let us talk about area of AEDF, AEDF and ABCDE. So if these two areas are equal, area of ACB is equal to area of triangle ACF. Now if I add this area on both sides, what will happen? Area of ACB plus area of ACDE, it will be equal to area of ACF plus area of ACDE. I have added equals to equals, so the results will also be equal. Now what are the results? ACB is this. If you add this area into this, you will get ABCDE. So area of ABCDE is equal to ACF plus ACDE. ACF is this one, and if you add ACDE, you will get AF, you will get AEDF or AFDE. You will get this area. So area AEDF. Right, this is the proof.